Okay guys, today we're going to look at section 5.3, rational numbers. Remember, rational numbers are any numbers that can be written as fractions. So this whole section today, we're looking at fractions. So remember that the top number in a fraction is called the numerator, the bottom number is called the denominator. How do we tell if two fractions are equal? Remember, we're going to use what we call the butterfly method, and I'm going to make these things go away. Sorry about that. So you use the butterfly method. So cross multiplying, cross product, is to determine the equality of rational numbers. Okay? I'm really not enjoying this green highlighter, but it is what it is. Okay. Next, it says determine if these are equal. Alright, so we're going to cross multiply. So we're doing 3 times 32. And we want that to be equal to 8 times 12. Well, 3 times 32, if you have your calculator handy, is 96. And 8 times 12 is also 96. So this is, yes, these two are equal. Okay, now the next one, 39 times 108. And we want that to equal 116 times 35. Take a minute on your calculator, type in 39 times 108, and that's 4,212. And 116 times 35 is 4,060. These two numbers are not equal, so these fractions are not equivalent. Now we do 1,419 times 220 and 1,892 times 165. So when we multiply these first two numbers together, we get 312,180. And on the second one, we get 312,180. So these two are equal, so these fractions are equivalent. Okay, awesome. So, how do you simplify rational numbers? So to simplify rational numbers, we call it reducing the rational number. It's when all the common factors have been canceled. We can say that the number is in lowest terms. So we find the biggest number that will go into both the top and the bottom. And when we divide that out, that we're left with the simplest rational number. All right. So we're moving on to this right here. So let's see. 48. Okay, so 48. You can do 6 times 8. And we go, can we either divide 6 or 8 into 72? And the one that we know very easily is 8 times 9. Yes, 6 will go into it, but 8's a little bit bigger number. So, the 8's cancel. So we're left with 6 times 9. But we can reduce this again, because 6 is 2 times 3, and 9 is 3 times 3. This allows us to cancel the 3's. So the answer to this problem is 2/3. Okay? Now, let's look at this one. This is a big number. Let's add up the digits and see if we can divide it at least by 3. So 1 and 8 is 9. That's 13. 13 and 8 is 20. So 9 will not go into it, but 3, let's see, 16, 17, that's 21. 21, excuse me, I can't add today. So 3 will go into it, but 9 will not. 2 will go into it, so 6 will work. Let's see if this will work with 6 as well. 2, 3, 4. 4 plus 2 is 6. So 6 will work here as well. because 3 and 2 both go into it. So let's see how many times 6 will go into both of these numbers using our divisibility rule here. So 1848 divided by 6 is 308. And then let's see how many times 6 will go into this one. 352. Okay, so that allows us to take 6 out. So now we're left with 308 over 352. Okay, so this adds up to be 11. So that won't work. So let's see. Let's try 2 will work. Let's do the last 2 digits. 4 will go into this and 4 will go into this. So let's see 4 times what gives us each of these numbers. So 308 divided by 4 is 77. 352 divided by 4 is 88. Okay, now I don't want you just using your graphing calculator, so I'm probably going to be giving you a little baby calculator that only does dividing on it, so you're not going to be able to just do it on your graphing calculator. So now we have 77 over 88, and this one should jump out at you that we know 11 goes into both of these. So 11 goes into both. And this gives us 7 over 8. They have no numbers in common because 7 is prime. And that's your answer. Okay? Now, adding and subtracting rational numbers. Remember, when we're adding and subtracting fractions, we need common denominators. Okay? When adding rational numbers with different denominators. Okay? We rewrite both fractions in a form where they have common denominators. For example, when we have 6 and 4, yes, you could use 24, but you could also use 12. That would probably be what most of you would say. If you use 24, 24 will work. You'll just have to reduce it at the end. Okay? Alrighty. So here we go. 5/6 plus 3/4. We're going to do it the way they said it in case you're not very good at finding common denominators. You can just multiply the two together and that can be your common denominator. So we'll make the common denominator here 24. Now, when we do that, we changed the bottom number. Okay? We changed the bottom number, so the top is extremely jealous of the bottom, and it goes, okay, so you multiplied 6 by 4 to get this 24. So if you multiplied 6 by 4, 5 says, I want to be multiplied by 4. Then 4 got multiplied by 6 here, so 3 wants to get multiplied by 6. So this gives me 20 over 24 plus 18 over 24. And that gives me 38, because you add the tops, keep the bottoms, over 24. Okay, these will reduce by 2. So this is 2 times 19 and 2 times 12. Okay, all right. And then the 2's cancel. So the answer to this is 19 over 12. Okay. Next, let's multiply 18 times 8, and that's 144. So 11/18 minus 3/8. So 18 times 8 is 144. Okay. So we multiplied by stuff. We multiplied 18 times 8 to get 144. So we're like, okay, if you multiplied the bottom by 8, the top wants to be multiplied by 8. Here, 8 times 18 gives you the 144. So you're going to multiply that there. Now, 8 times 11 is 88. 18 times 3 is 54. 88 minus 54 gives me 34. Okay, 2 will go into both of these. Oops. 2 times 17 and 2 times 72. Okay, so those go away, and this gives you 17 over 72. And 17's prime, and 17 will not go into 72. And there we go. Now, multiplying and dividing rational numbers, you do not need to get a common denominator. You can multiply straight across, or you can cross cancel. Okay, that will help you for multiplying. Okay, so here we go. When I say cross cancel, that means that they have something in common, okay, that will be divisible. So 4 and 15 have nothing in common. 3 and 3, they're both divisible by 3. 3 goes into 3 one time, 3 goes into 3 one time. Then you can multiply straight across. 4 times 1 is 4. 1 times 15 is 15. Okay. This one, 18 over 25 times 10 over 81. Okay, so 18 and 81 are both in the 9s family. Okay, 9 goes into 18 2 times. 9 goes into 81 9 times. 10 and 25 are both in the 5s family. 5 goes into 25 5 times. 5 goes into 10 2 times. So that leaves me with 2 times 2 is 4, and 5 times 9 is 45. And if you reduce it correctly, you won't have to reduce these fractions. All right, now we have 9/4 times negative 12/5. Now when you have that negative sign, it can only go with one piece. It doesn't go with the top and the bottom. So I'll usually put it with the top. Okay, so 9 and 5 don't have anything in common. They're not in any family but ones, and that doesn't help us. 4 and 12 are both in the 4s family. So 4 goes into 4 one time. 4 goes into negative 12, negative 3 times. So that we have 9 times negative 3 is negative 27, and 1 times 5 is 5. Okay, now in division, remember the saying that you learned when you were dividing fractions was keep, change, flip. And what that stood for was keep the first fraction the same. Change division to multiplication. Flip second fraction. Okay, and they did that right here. Keep your first fraction the same, change this division symbol to multiplication, and flip the second fraction. And when you see this, I like to call these funky fractions, okay? Funky fractions. And the reason I call them that, these are technically called complex fractions, but I think fractions in the word complex gives you a complex. So I renamed them funky fractions a long time ago. And funky fractions are just really a division problem. So don't let it stress you out. So that is the same as that. So keep the first fraction the same, change division to multiplication, and then flip it. Okay? All right. So here we go. All right. So we keep the first fraction the same, 25 twelfths. Change division to multiplication, and then we're going to flip this bottom fraction. Now we see if we can just reduce things because it's now multiplication. So 25 and 10 are in the 5's family. 25 divisible by 5 times. 5 goes into 10 2. 3 and 12 are in the 3's family. 3 goes into 3 1 time. 3 goes into 12 4 times. So this gives me 5 times 1, which is 5, and 4 times 2, which is 8. All right, same thing here. Keep the first fraction, make this multiplication, flip the second fraction. Nothing is the same here. They're not in any family other than 1. Here, because they're both prime, here they're in the 3's family. So 3 goes into 6 2 times, 3 goes into 9 3 times. So this becomes negative 11 times 3 is negative 33. 2 times 7 is 14. And that's your answer. And if you need to go back and listen to these again, feel free to rewind and watch them again. All right. So suppose you were drawing a landscaping plan using a graphics package, such as Adobe CS3 Master Collection, and have drawn a rectangle measuring 8/3 of an inch long by 5/6 of an inch wide, representing a rectangular Japanese garden. If you scale down, okay, so the first one's going to be a scale down the length of the factor by 3/4 and the width by a factor of 9/8, what are the new dimensions of the side of the garden in your drawing? Okay, so we're scaling down. Okay, so we're going to scale down the length first. Our length was 8/3. We're scaling down by a factor of means multiplication, 3/4. Okay, so we can reduce these to be 1s. These are both in the 4's family, so that's a 1, that's a 2. Okay, so 2 times 1 is 2, that's 1. So this is 2 over 1, which is 2 inches, is the new length. Now, the width, they said was 5/6. You're scaling down by 9/8. Now, the only one that can reduce is the 6 and the 9. You're reducing them by 3, so that's a 2, that's a 3. So this becomes 15 over 16 inches. So the new dimensions are 2 inches by 15/16 of an inch. Okay, then it says, how does the area of the new rectangle compare to the area of the original? Okay, so remember, area of a rectangle is length times width. So we're going to do the old first. So the old one is 8/3 times 5/6, and the new is 2 times 15/16. And you can put the 1 under here so that works. Okay, so now we look to see if we can cross cancel anything. These are reducible by 2, so that's a 4 and that's a 3. This is reducible by 1 and that's an 8. So this one is 20/9, and for area is square inches. Then you do 15/8 square inches. And when you're comparing, you do new, because it says how does the new compare with the old. So we're going to do new 15/8 divided by 20/9. Remember, this is keep, change, flip. So we're using all of our facts here. So this is going to be 15/8 times 9/20. These are in the 5's family, so that becomes a 3. That becomes a 4. And this says that it's 27/32 of the old. So that's 27/32 of the old size, of the old area. Okay? And there we go. All right. Mixed numbers. Okay? When a numerator is greater than the denominator, it's called an improper fraction. So when the top is bigger than the bottom, that's an improper fraction, like 125/8. Okay? So what you have, or 123/8, excuse me. So what you have to do is divide the bottom number into the top number. Okay, so we divide the bottom into the top number, and then the way we write it, some of you might have learned this when you were learning it. We work in a clockwise manner. Some of you might have learned it as rock around the clock. So B went into A Q times with R left over. That's the remainder. Okay, so you put the remainder over the divisor. Okay, and if you want to see like the actual okay, so let's do an actual problem. Okay, so 6 into 45. 6 will not go into 4, but it'll go into 45, the closest one. So 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. That's as close as we're going to get. So 42. So we subtract and we have 3 left. You're not going to get 6 to go into 3. So what we have is 7 3/6. But remember, this can be reduced, okay? This can be a 1, this can be a 2. So this is really 7 1/2. Okay, let's divide 8 into 133. So 8 won't go into 1, but it'll go into 13 one time. 8 times 1 is 8. Subtract, that's 5. We bring down the 3. So let's do some 8s. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. So it's going to be a 6. That's 48. When we subtract it, that gives me a 5. I can't divide 8 into 5. So remember, around the clock. Okay, so that's going to be 16 5/8. Then check your little fraction here to make sure you can't reduce it, and we can't. And that's your answer. Okay. All right, next. Converting a mixed number to an improper fraction. Okay, so what you have to do, let's say we have Q R over B. Remember that you do Q, B times Q plus R, and you get that number over B. Okay? So, in this problem right here, we're going to do 5 times 7 plus 2 over 7. So that's 35, 36, 37 over 7. And that can't be reduced. Okay, here we're going to do 11 times 8 plus 3 over, oops, that should be in black, sorry, over 11. Okay, so that's 88 plus 3 is 91 over 11. Now, just in case you see one with a negative sign out front, just stick it on the answer. You don't have to include it in the math. You don't make that a negative number and then have to subtract. Okay? Now, writing a rational number in decimal form. All you have to do is divide the denominator into the numerator. And if it won't work, you put a decimal point and a 0. So 8 goes into 5 6 times. Okay? 6 times 8 is 48. Subtract that, that's a 2. Add a 0, bring it down. 8 goes into 20 2 times, which is 16. Subtract, that gives you 4. Bring down the 0. 8 goes into 40 5 times, which is 40. Now you're either going to go until it ends or till it repeats. Okay? Next, 16 into 7. 16 will go into 70. I'll help you out here. That's 4 times. That's 64. Subtract, that's 6. This will go into 60. If that went 4 times, let's see 3 times for this, because it's 10 less. Okay, so that's going to be 48. That's going to be 12. Going to go 0. 16 into 120, that's going to be a 7. And what you would do is just try a number. So 16 times 6, 16 times 7, see which one gets you the closest to 120 without going over. Okay, 112, so that's going to be an 8. Going to add another 0. 16 will go into 85 times evenly. So that one took a little bit. And these are not going to be your favorites. Okay, doing this by hand, you haven't had to do basic math by hand in a long time, but it will not kill you, I promise. Okay. And the last one. 111 into 82. Well, you're going to have to add the 0. This is 0.7. 7 times 111 is 777. This will be 430. This will go 3 times. And this is going to be 333. And that's 97. Hang on 1 minute. I wrote that a little crooked. That'd be 43. Bring down the 0. That'd be 333. That'll be 97. Bring down the 0. That'll be an 8. That'll be 888. That'll be an 82. And we'll have a 7. 777. And if you look, we have started the pattern over again. And we can stop right here because this is going to be 0.738, and you're going to put a bar over the 738 because after that 8, it's going to go back to 7. Okay? All right. All right, last page. Decimal expansions of rational numbers. Okay, so if you are trying to write a decimal, when writing a rational number in decimal form, we always get a terminal expansion, like we did in example 9. Okay, A and B. Or an infinite repeating expansion like we did in C. Okay, so if we have one that ends, look at the position of your last figure. Okay, that 4 is in the thousands, tenths, hundredths, thousands. Remember, that is thousands. So it's 124 over 1,000. Then just reduce that fraction. Now, if it's a repeating, okay, so if it's a repeating one, I can give you all the detail part, or the rule is going to be, the rule is 1 less than the position is the denominator. Okay, 1 less is the position. So what that means is 0.36 repeating This is in the hundreds. Okay, this is in the hundreds. So you're going to put 36 over 99. And then you would reduce this. Okay, so you would reduce this. Let's see. 2 will go into that. Let's see. 3 will go into that. Let's see if 9 will. That adds up to be 9. That adds up to be 18. So 9 will go into these. So divisible by 9. So 4 times 9 and 11 times 9. So that's 4/11. Let's look at another one. 0.634 repeating. So this would be, whoops, you can't see that. 634. This is in the thousandth. So 1 less than 1,000 is 999. So that's 27. That's 9 and 3. That's 13. So it's not divisible by 9. Not divisible by 3, so it's not divisible by 6. That's not divisible by 2 on both. So this is your answer on this one. Okay? And that's the way that works. Okay? If you have any questions, let me know. Feel free to listen to this again if you need to. All right, thanks, guys.